there guys, this is Mr. Herbst here, and today our focus is going to be on what we call the redshift and blueshift. Understanding what the redshift and the blueshift is requires a deep understanding of the Doppler effect. If you are unfamiliar with the Doppler effect, please take a look at my video right here before continuing with this video. So to start with, the redshift and the blueshift is a phenomena that occurs with light. Over here we have our red light, and over here we have our blue light, and in between we have our Roy G. Biv. Now red light has a wavelength of about 7 nanometers, and blue light has a wavelength of about 4 nanometers. Next, let's take a second to review the Doppler effect. The Doppler effect is most often observed with sound. When a source of a sound is coming towards us, the source of the sound is actually moving into the waves that it's creating. Therefore, the waves get more closely compressed and the frequency goes up. So the sound that you hear from that source of that sound is going to actually be higher than it actually is. And then suddenly, when the source of that sound goes away, suddenly the frequency drops and the pitch drops. So as I was saying in my last video, the Doppler effect doesn't just affect sound, it can also affect light and water. When it affects light, we refer to this as the redshift and the blueshift. To fully understand the redshift and the blueshift, we must understand that different colors of light have different wavelengths. Thus, you ever heard of Roy G. Biv? This is where Roy G. Biv comes from. Our reds way up here have a very big wavelength, thus they go by less often. And our violets and blues down here go by very quickly, thus they have a higher frequency because they go by more often. So let's go ahead and consider that we have two stars. These stars are giving off a known wavelength of light. Now if one star, the one on the left, happens to be moving away from us, the light waves are going to be stretched out. Thus they are going to appear more red in color. The faster that star is moving away from us, the more red it is going to appear in color. Vice versa. If the star on the right, say, is moving towards us, it's going to appear more blue in color than it actually is. So with that said, there's something very interesting that occurs in our known universe. Almost all of the galaxies and all of the stars that we see in the universe are redshifted, which means all of them have a larger wavelength than what you would predict, which means that almost all of the stars and all of the galaxies are moving away from us. And what's even more interesting, that we find that the farther they are away from us, the more redshift that we see, which means they're moving away from us even faster. So what that explains is that as the universe is getting bigger, it's getting bigger at a faster rate. That's right, the universe is accelerating the rate at which it is expanding. Also, if we go ahead and reverse time, it almost appears that all of these galaxies and all these stars came from one central point. That's what we call the Big Bang. But that's another video. Anyway here guys, that concludes the redshift and blueshift. This is Mr. Herbst. I'm signing off folks. Y'all have a nice day.